I'm keen, you're keen, we're all keen for alkenes! Yay! Alrighty, so we've just been looking at alkanes. We're now looking at alkenes, which are unsaturated hydrocarbons which contain at least one carbon-carbon double bond. So remember how I said before that when you think saturated, we think saturated with hydrogens. The molecule is holding as many hydrogens as it can. In alkenes, we have two less hydrogens in the molecule per double bond. So the general formula for an alkene is CnH2n. So just like I said before, for each carbon atom there are twice as many hydrogens. And the suffix for alkenes is ene. So we have ethene for those two carbons, propene for 3 carbons, butene for 4 carbons in that molecule. So alkene nomenclature, our job is to still identify the longest carbon chain in the molecule. We then have to identify the carbon which has the double bond. So the carbon that the double bond starts on. We count from the carbon closest to the end of the chain. So in this example here, we have two of the same molecule. These are the same. They are both a pentene because 1, 2, 3, 4, 5 carbons. This example, this name is incorrect because we've counted from this end of the molecule, 1, 2, 3, 4, 5, where we should have counted from this end of the molecule, 1, 2, 3, 4, 5. We want this number with the carbon double bond to be as low as possible. Here again, pentene, again, 5 carbons. Counted from this end, 1, 2, 3, 4, 5. See that double bond is starting on 3. 1, 2, 3, 4, 5. This is the correct answer. That is wrong. That is wrong. This is correct. This is correct. Okay, so in this molecule we have a carbon-carbon double bond, so we know that it's an alkene. We're going to start counting from this end because we want that number to be the lowest. 1, 2, 3, 4. It's 4 carbons long, so we know that it's going to be a but-1-ene. There is a branch, a substituent coming off carbon number 3. See here that it has 1 carbon, so we know that it's going to be a methyl group. 3-methyl-but-1-ene. We could also draw this in 2 other ways. I'm going to show you with a molecule in just a moment. We could draw its line structure. So carbon number 1, 2, 3, 4. Of course, we know that all of these carbons must have hydrogens coming off them, so there'd be 1 here. 1, 2, 1, 2, 3. 1, 2, 3. 1, 2. Here we have another alkene. This one happens to have 2 sets of double bonds in it, but thankfully it is symmetrical, so that makes counting from either end correct, so whichever way you'd like is fine. 1, 2, 3, 4, 5, 6. So we know that it's going to be a hexene. Now it's important that you, sorry, I need some more space. It's important that you tell the person reading this that there are 2 of them. So we're going to use kind of like a prefix to our suffix, di-ene. You also need to tell the person where those double bonds start. So I'm just very clearly labeled 2, 2, 4. So the double bonds, we know that there are 2 of them in this molecule. They start on carbons number 2 and 4. And there's nothing else exciting in this molecule, so that's it. Hex 2,4-diene. in this molecule we have a 5 carbons, so we know it's going to be pent something. There's a double bond here, so we know that our suffix is going to be -ene. Remember, our alkenes are more important than our alkanes. So these substituents, although if I count from this end 1, 2, 1, 2, that would make this number the lowest. We need to count our carbon chain in priority to make that alkane the lowest number. So 1, 2, 3, 4, 5. Our alkane starts on carbon number 2, so this is pent 2-ene. There are 2 substituents, 2 branches coming off here. They're both the same. They're both methyl groups because they both only have 1 carbon in it. So it's going to be a dimethyl. And where are they? They're on carbons number 2 and 4. 2, 4, dimethyl pent 2-ene. Molecule is a little bit more exciting, bigger than the other ones we've been looking at. And you might be so inclined as to go ahead and start counting that carbon chain and tell me that it's nonane, but you would be wrong, which is totally okay because that's part of the learning experience. What's important to notice is that this is an alkene, and that alkene needs to be in your parent chain, the longest chain. So we're going to start counting from here. 1, 2, 3, 4, 5, 6, 7, 8. Remember, I counted from here, starting here, because I want that alkene to be on the lowest number, 3. If I counted from this end, it would be 1, 2, 3, 4, 5, 5, and that's bigger than 3. So it's 8 carbons long. We know that it's going to be an oct something ene. That double bond starts on carbon number 3, so it's an oct 3-ene. Now let's have a look at its branches, its substituents. It has one here, which is 1, 2, 3, 4 carbons long, so it's going to be a butyl group. And here we have a chlorine. Chlorine sitting on carbon number 6, and it gets the name chloro. Quite frequently our halogens will find their ways into hydrocarbons, and they all get this very simple name. So fluoro, iodo, bromo, and chloro. Those are the only 4 that you'll experience anyway. Okay, so in terms of naming this bad boy, B comes before C. So 4-butyl, 6-chloro, oct 3-ene. A mouthful, but methodical. It makes sense. I thought I'd be a little bit crazy and just make you this absolute nightmare of a alkene that has all of the halogens in them, just for fun, because you know what, we can do this. So first up, identify how long that main chain is. It's 1, 2, 3, 4, 5, so it's going to be a pent something. Look at that. The alkene starts on carbon number 1, so you don't need to put pent 1-ene in there. We just know it's pent-ene. It's there in the name. You don't have to put 1s in. 1, 2, 3, 4, 5. I put all these purple and yellow, blue, green circles because honestly I needed to just help myself a little bit. So we've got alphabetically, bromine is going to go first. There are 3 of them in this molecule, so it's going to be a tri-bromo. I might start over here. They are sitting on carbons number 2, 3, and 5. So 2, 3, 5 tri-bromo. Next we'll have chlorine. There are 2 of them, so it's going to be a dichloro. They're sitting on carbons number 2 and 3. dichloro. Right, you need to move because that's not going to fit. Next in the alphabet, F, we have 2 fluorines. So another di on carbon number 1 and 5. Difluoro. And iodo, there are 2 of them. Both of them are on carbon number 4. So it's 4,4 diiodo pentene. Beautiful. It's that. Before we move on from alkenes is talking about geometrical isomers. So geometry, we're thinking about in space, isomers, the same type of atoms, but different molecules. So alkenes can do cis and trans isomerism. Due to the lack of rotation around a double bond, it is very much fixed in space. So when we draw them like this, where we have the substituents or like the branches on the same side of the double bond, is called a cis isomer. The same molecule, because there's all the same atoms arranged kind of the same in space, 2 methyl groups sitting on opposite sides of the double bond is the trans isomer. You may think, well, what difference does that make? It actually affects the way that the molecule behaves, but we'll get into more detail around that later.